there is no way that he has bad internet. He's 5 minutes from my house, and my internet is great.
Maybe he could just like sit in your driveway and stream off of yours.
He probably has a different provider and probably pays for a different internet speed.
Yeah, but the thing is, he said his internet isn't working. The only way your internet wouldn't work is if the internet was down for everybody, basically, or if he has a broken router, which I highly doubt.
It could definitely be his router, or just the fact that everyone in his family is all using the internet at their house.
Yeah, everyone in my family is doing that as well, all at the same time. And there's 9 of us here right now, and 3 dogs, but they're not using the internet. You just hear them bark every now and then. So I think you've already been reminded of this today, but I guess the more you hear it, it'll stay in your mind. Something about art and Mrs. Knorr and Brian Stout. Shout out to Brian who turned in his art.
Yeah, how am I the only one? I'm usually the one that doesn't do the assignments.
I don't know. Maybe Lauren reminded you?
I have a question, Brian.
I just looked on and saw him do it and did it.
What exactly did you do? Because I tried doing it yesterday, but I didn't understand her instructions.
She said it was easy. You just have to take a picture of something. You don't even have to draw something.
I forget what it was I did, but I just took a picture.
So, Brian, did you just take a picture? Because she was also asking questions. I'm not sure if I was supposed to answer those or not.
And I didn't know if we were supposed to.
Well,
did you answer any questions, Brian?
I don't think so. I'm gonna go look at the assignment again.
Okay.
Send her an email if you don't understand the instructions.
I don't think she got back to me though.
Okay. She should shortly. Maybe not right now, but I don't think the theater's open, so I don't think she's there. So she should be pretty responsive. All right. How about those angles of depression and elevation for us?
Why do they call them angles of depression?
I know. It sounds like they're depressed, but I think we're just because it's going down.
Wait, which page is it again? I keep forgetting. Isn't it
Page 611.
Okay.
Must be a psychiatric flow.
Yeah. Yeah, maybe that's why I've always liked angles of elevation better. Okay. Let's pull out our homework.
I can't understand anything.
Anything?
Everybody keeps cutting out.
Oh.
Everyone's cutting out.
Sorry, Lily. I thought you meant about the angles. Maybe if you log out and log back in. And if that doesn't work, then I'm out of ideas. But also, you could check with Mr. Gilger. Okay. Page 611, number 4.
Wait,
I like number 4 because they already drew the diagram for us. Okay. A hockey player taking a shot from 20 feet away from a 5-foot goal. If the puck travels at a 15-degree angle of elevation toward the center, will he score? So this is a yes or a no. Hang on. I'm going to start a session. I like to pull up a list of you guys so I can just go in order and I don't forget anyone. So Aristotle, you're on my list. So what did you get for number 4?
I said no. It's going to be 3.5 inches too high.
2.5 inches too high.
Yeah.
I got 4 inches too high, but I don't know if you can. I might have to write it on. You're not going to see it on there. Okay. I'll write it on my board. Okay. So you had your triangle, and we had 15 degrees, right? And then it was 20 feet and X. So your triangle kind of looked like that?
Yeah.
Did you use tan?
Yep.
Okay. So tan of 15 degrees equals X over 20. All right. So X is going to, we just have to multiply those. Tan 15 times 20. Let me try it again. So I was getting 5.4.
That's what I got.
Okay.
When would you actually need to know that, though? Oh, that person is taking a shot. That must be around a 15-degree angle. Okay, quick, get out your calculator before it goes in the goal.
I know.
And so what would dip down after the initial shot? So it would start at 15, but then it would be at a lower and lower angle?
I get 5.35, 3.5.
Oh, yeah, that's what I got. Also, so it's like 5 point. We're just rounding it to the nearest 10. That's why I got this.
Okay.
Yeah.
Yeah.
Okay. So I see what you're saying. All right, that's good. So it's a no because it's too high. All right, number 5, mountains. And then I think for this one, I was like, oh no, I have to draw something on my own. Find the angle of elevation to the peak of a mountain for an observer who is 155 meters from the mountain, if his eye is 1.5 meters above the ground and the mountain is 350 meters tall. I like this way where it said his eye is there. It didn't say it was like the top of his head. Okay. Number 5. So after Aristotle, I had Brian. Brian, what'd you get for number 5?
49 degrees.
Got something different than that one.
Okay.
Let me go to the next person also and see what Colby got. Colby, what did you get?
I got 4.5.
4.5. What did you get, Brian?
I got 49 degrees.
Okay. And you got 4.5. Grace, what did you get?
Oh, wow.
66 degrees.
I got 66.
At
Okay.
like 4.5 degrees, that would be like...
No, I said 45.
Oh, that makes sense.
Okay, so I'm going to show you my triangle. There's my mountain. All right. I need to get markers that'll write better. Okay. And 348.5. And we're looking for this angle. What else do I know? Find the angle, 155. Oh, this is the 155. Okay. Find the angle of elevation to the peak of a mountain for an observer who's 155 meters from the mountain if his eye is 1.5 meters above ground and the mountain is 350 meters tall. So I did 348.5 here because his eye is 1.5 meters above. So I subtracted that 1.5. Okay. And I need to know this angle. I don't know this angle. And this is opposite over adjacent. So it's going to be tangent. All right. So I'm going to write an equation and say the tangent of x equals 348.5 over 155. Okay. But I need to find the degree, so I have to do inverse tan. All right, so I'm going to say, okay, x equals inverse tan of that. All right. So x is going to be inverse tan of 348.5 divided by 155. So take your calculators out. All right. Make sure you're in degrees. Type in 348.5 divided by 155 equals, and then do your inverse tan. And you should end up with this 66 point, so about 66 degrees.
Yeah. Well, I got 65.5.
Okay. All right. It might depend on like where your calculator is cutting off the decimals, but you should do it. So, but anyway, that's how you want to do it. Inverse tan. And the other thing you have to remember is to deduct the 1.5 meters off the height of the mountain. Okay. That's how you do that one. Number 6 was a water park.
Yes.
Yeah, I think this one's miserable.
Water park that doesn't know the height of its own slides that they constructed.
Yeah, let me see. 2 water slides are 50 meters apart on ground level. From the top of the taller slide, you can see the top of the shorter slide at an angled depression of 15 degrees. You know, the top of the other slide is approximately 15 meters above the ground. About how far above the ground are you? Round to the nearest tenth of a meter. Okay. Did they get? They gave us the 50. Okay. Just looking to see what I did with that one. Okay. Okay. What did you get for that one, Lily? Lily, are you still with us? Can you hear us? No, I think Lily might have popped out. Okay. And Luke is not here. All right, so I'm going to go back to Aristotle.
Now this one, this is the one I have a question on.
Okay.
So when the angle of depression comes down, it's not forming a point for the triangle. So how does that work? Because my drawing would look here. Wait, my drawing is going to look like this. Because the smaller water slide doesn't form a point.
Well, yeah, you can put another parallel line straight across, like from the top of the smaller platform, like it's on the right, it says 15 meters. From there, put like a dashy line straight across. So you'll be making a parallel line and another 15-degree angle because you'll have opposite interior angles.
Or what you do, Aristotle, is you just draw it for the top of the smaller one being the bottom line of it, and then you just add that the other number to the back line when you're doing the equation.
Oh yeah. Okay.
Okay, yeah. So all right. This is 15. All right, so I'm trying to do the drawing on my whiteboard. This whole thing is X, I guess. Okay. Yeah, so what I did, I don't know if this drawing is going to help, but I put a 15-degree angle there. I drew like a parallel line and then did opposite interior angles. Right.
I get.
I'm just going to do, I want to try to find like this piece right here. I'm trying to find, because I already know it's 15 meters like from here down. So I want to try to find this piece of X. So I have 15 degrees. So I'm going to do tangent again. Tangent of 15 degrees equals
13.
X over 50. Okay. So tangent of 15 degrees equals X over 50. We're going to do tangent of 15 times 50. We get what did you get for that?
13.39.
Okay, good. 13.39. So we'll call that 13.4, okay? X equals 13.4. So now we have to answer the question. So this top piece here is 13.4. And remember, the bottom part is 15. So we have to put that together because they say how tall is the tall one, I think.
So 28.4.
That's it, 28.4 meters. Okay. One more of these guys. Brian, aviation. due to a storm, there's a pilot flying at an altitude of 528 feet and he has to land. If he has a horizontal distance of 2,000 feet to land, at what angle of depression should he land? Did you draw a drawing for this?
No, I have that thought in my head.
Okay, what did you get? What is it?
22 degrees.
22. I don't have 22. My book doesn't have 22, but
Okay.
I'll see what you. Let me see what Colby got for that one. Colby,
Got
what'd you get for number
22.
7?
Did you hear me?
No, I'm sorry.
22?
No, is that what Brian said?
I don't know.
Yeah.
Oh, got the same thing. Okay. Grace, what did you get? This is for number 7.
14 point. Here, I'm gonna do it again.
No, that's it. Tell me what you got, Grace. 14 point.
I think.
That's it. You're killing these, Grace. Good job. Okay. Let's draw a picture. We've got a plane. It's 528 feet up in the air. All right. It's got 2,000 feet to land. All right. So I'm going to put that along the bottom. And it's looking to where it wants to land, I think. It has at an angle, at what angle of depression? It has 528 feet to land. Due to a storm, he has at an altitude of 528 feet. If he has a horizontal distance, at what angle of depression? Okay. So the angle of depression is this. It's that angle there. But we know that we can say we have parallel lines. So this angle is going to be the same as this angle. Sorry, as this angle down here, right? Opposite interiors. All right. So I actually want to find this angle. And from this angle, I know my opposite and I know my adjacent. So I'm going to use tangent again. And I'm going to say tangent of x equals 528 over 2,000. Okay. So 2,000 times tangent of x equals 528. That's step 1. Step 2. I'm going to divide both sides by 2,000. So that'll be step 3. Tangent of x is 528 divided by 2,000. All right, so x is going to equal the inverse tangent of that because we're looking for the angle degree. So when we want the angle degree, that's when we use inverse. So x equals inverse tangent of 528 over 2,000. All right, so everybody try that one in your calculator. Inverse tangent of 528 divided by 2,000. See if you got what Grace got.
Wait, what were the numbers again? 5,000.
Inverse tangent. Okay, you're going to do 578 divided by 2,000.
I just rounded it up, though.
And then you round it to the nearest tenth, I think they said. Or they didn't say, but we'll round it to the nearest tenth.
0.
You got a 0?
So did I.
You did? All right, Brian, you're using the same kind of calculator as me, right?
Yeah.
Okay, so type in, clear it out, type 528 divided by 2,000 equals, and then hit second function, and then you should get like the little tan with a -1 button.
Uh-huh.
Hit that, and that should be your answer.
Okay. Yep, I
All
got
right.
that.
Colby, on yours.
Wait, I think I typed in the wrong number. I'm pretty sure I put 578.
Yeah, you had said 578 one of the times. So.
Oh, okay.
And that time it was radians.
Oh.
Wait. 528 2000.
Are you using the computer, Colby?
Yes.
Okay.
I can't tell if it's in radians or degrees.
Degrees. Let me see. Hang on. You want degrees, I think, to be like in bold and the radians to be in the light color.
Wait, so to the nearest 10th, you said?
Yeah.
I get 0.1.
All right, hang on. Let me try it with yours. I'm going to present so I can use the same calculator as you.
Okay.
All right. Okay. Let's try this. All right. So are you using this button? Arctan? It'll come up, say
Yep.
Arctan on yours. Okay. Let's see. Can you see my screen?
Yep.
Okay, so I'm getting that what Grace got, the 14.8.
All right, I got it now.
Okay.
I had the 2000 outside of the parentheses.
Oh, okay. All right, gotcha. Okay. In your Google Classroom, I want to show you that while I'm presenting. I put in an assessment to kind of finish up this chapter. The next part's on law of sine and cosines, which is trig pretty much. They put that into our book. So I'd like to finish this one up. It says I posted this. Let's look under classwork. Because you won't be doing all the problems. All right. Did I attach it is the question. Classwork. Hopefully. Oh, there it is. I was going to say, maybe I didn't attach it. Sometimes I get interrupted in the middle of something and forget that I didn't do it. Okay. Okay. So there's a test. Find the geometric mean for number 1. Numbers 2 through 5, it's the altitude, and then you using the geometric mean to find these sides. So you guys can do all of that. These are 30, 60, 90 triangles here. This is right triangles, and you can use sine, cosine, or tangent. This one, you'll have to draw a picture. 30-foot tree casts a 12-foot shadow. Okay, so you're drawing the triangle. They give you the little drawing for 12. 13 is the plane type. And then 13 is where I want you to stop. Okay. So you're going to do 1 to 13. And we're not doing the vectors, but I think you can do the bonus, right? Does this look familiar to you?
Yeah, probably.
Okay. So 1 to 13 and then the bonus. So that's for today or tomorrow. You know, we don't really have like class tomorrow where we'll see each other, but I'll be here and I'll be available all day. You could send me an email, and then we can jump on Google Meet if you need to go over, like if you're stuck on one of those and you have a question. Okay. And do again, just make a Google Doc and send me your answers. You know, unless you want to print that out and write your answers on it and send me a picture. I don't care, however, but send me those. Send it by Sunday night, and that way next week we'll be able to start a new chapter. Do you guys have questions for me?
No.
Okay. Yeah. So if I were you, I would put in my mind, not Sunday night, but I would put in my mind that's either homework for like today or tonight, or that's my schoolwork for tomorrow, and then, you know, not have to worry about it on the weekend. So, unless you're like super busy today and tomorrow.
So that's our test?
Yep.
Just 1 to 13? Or did I miss something? Okay.
No, you're right. 1 to 13. And then if you want to do the bonus, you can do that for extra points.
Okay.
Okay. Yeah. And if you have questions about it, you know, I'm here 2 to 3 today after I teach, and then I'm here all day tomorrow if you have any questions for me. Or even if you're working on it tonight, you can send me an email. Let me know that you're stuck on something, okay?
Thank you, Mrs. Palmer.
You're welcome. Have a good night, guys.
Thanks, you too. See ya.
Bye-bye.
Good day.
Did you ask me something, Brian?
It doesn't matter.
Okay.